Composite functions. So just a quick reminder about things we should know. A function is a relationship that takes one element from one set and maps it to one and only one element from another set. So if we say that these are two sets, if we have an element here, it can map to an element over here. What we can't have is this element mapping to another element over here. We can map to one and only one element. We could have elements over here that each map to a different element over here, in which case we have a one-to-one function, or we could have the situation where a second element over here maps to this same value, and that would be a many-to-one function. The domain is the set of numbers that are being input into the function. So those are the x values. So here, this set would be the domain, and then the range is the set of numbers that are outputted from the function. So those are the y values. So here, this is the range. Composite functions are when you have several functions combined and the inputs into one function are determined by the outputs of a previous function. So here's a diagram that shows that. So here we have a domain, and these values are going to be input into this function called g. And g does something to these values. We can see what it does just here. And there's an output here. So the values that end up coming out here then go in to this function, the function f. So the values in the middle act as the domain for f. Then we have values come out. So overall, for the combined function, this is the domain, and the values that come out would be the range. The combined function notation, this function just here, we can see that's the output, is read as f of g of x and can be written as f of g of x like this, f o g x, and fg of x, and the brackets here don't have to be square either. Quite often these brackets are round brackets. So other than the very first function, because there could be several functions along here, function inputs are determined by the outputs of the previous function.